Alright, so today we have you working on solving absolute value equations and inequalities. So I had you start with these first 5 problems. Let's start with Tim. Tim, what'd you get for number 1? 8. 8 is correct. Tim, pick somebody. What'd you get for number 2? 3 is correct. Pick somebody. What'd you get for number 3? 17 is correct. Pick somebody. Okay. 1/2. Perfect. Okay, so you want to write that down then if you didn't get that answer, so that will help you out. Pick somebody then. Kai, last one. 0.25 is also right. Okay, so in case you weren't able to hear those answers, here they are again. Okay, all 5 of them. Make sure they are correct. But what do you notice about the absolute value? Somebody raise your hand and tell me, what do you notice? They are always positive. That's right. Okay. In fact, absolute value, does anybody know what it means? That's exactly the definition I was looking for. The distance away from 0. And no matter if you're going forwards or backwards, distance is always positive, right? Okay, if you decide to run around the track, that's a positive distance. If you decide to run around the track backwards, still a positive distance. So, at this time, turn in your notebook to your table of contents and go ahead and write down our objective at the top. And then turn to that next page and write that objective again. So, here's our first example. And I want you to go ahead and write that down just so you can see that example. But we can actually use a number line to solve an absolute value equation. And notice that there's 2 answers to it. So in this case, the absolute value of m equals 2.5 is negative 2.5 and 2.5. So I'm getting 2 separate answers. Because if I plug that in, the absolute value of negative 2.5 is positive 2.5. And the absolute value of positive 2.5 is 2.5. So both answers give me the same thing, don't they? Okay, so take a minute and go ahead and copy down that example just so you can see it on a number line and you can see that solution. I'm going to move you on now. So on this next slide, I have some problems I want you to try. Just some basic problems. And if you can look back at the last example, those 3 problems should be pretty simple. So go ahead and write those 3 down and solve them quickly. All right, so we have somebody coming up to the board. Go ahead and answer letter A for us. It's already set with a pen. That's fine. I had it on yellow for an earlier activity. So notice 2 answers. Go ahead and hand off the pen. Nice and simple. But what I'm trying to ingrain in you right here is that when I have an absolute value equation, I always am getting 2 answers for the most part. I say for the most part because eventually we'll see some that don't. You get to hand that off. I knew it was coming to you. It was the look you gave them. Perfect. So those are my answers there. Any questions? All right. So those are the exact answers that we've already been given. So here's some rules. And I'm the type of person, I need to be able to look back at notes, not just examples. I need to be able to read something. Now, like I talked to you before about, though, is that you can abbreviate these. So I do want you to write these rules down, but if you can abbreviate anything, you may, so that you understand it. But I've given you here 2 rules to be able to solve the absolute value equations. And then I've given you some hints. And those hints may come in handy during our chapter test. So what we're going to do right now is I'm going to give you an equation. And we're going to take a minute, write it down. And then we're going to follow these steps to go ahead and solve it. So, let's see where my equation is. right there. We're going to solve the absolute value of 2x minus 1 plus 5 equals 11. And beside it, I've actually written the steps, mainly because I like to match up my words with my equations to help me out a little bit. So what do I need to do first here? Okay, how would I do that? Perfect. Go ahead and subtract 5 from both sides. I did spell it wrong. Let's fix that real quick. Let's fix that. There we go. Thank you, Tim. Alright, so I subtracted 5 and got this lovely answer. What do I need to do next? Now that I've gotten the absolute value alone, what's step 2? Not yet. Set up 2 equations. So what Lucas is doing is actually just reading step 2 right off of what he wrote down. So I have to set up 2 separate equations. What else can you tell me about those 2 equations, Lucas, according to what you wrote down in your notes? Antonio. There you go. Okay? Set the first equation to a positive, the second equation to a negative. Did I say anything about the inside of the absolute value signs? No. You always leave that alone. That may be something you want to write down. A lot of students think I want to change that -1 to a +1. No, never, never. You leave that stuff alone. So instead, I'm going to set up 2 equations here. One with a positive 6, one with a negative 6. That is the only number that changes. All right. So now these look like equations you've solved before for me, correct? Go ahead and take a minute and solve them. So, Lucas, who do you want me to pick on for the first answer? David, what did you get for 2x minus 1 equals 6? Perfect. Absolutely perfect. Antonio, who do you want for the second equation? Colette, what did you get for the second equation? Close. Close, close. You actually just have your 2 and your 5 switched. -5 over 2. Okay? So, now we've solved each equation. Any questions? All right. So the equations are the easy thing. Now, if you had Mr. Ryan or you had Mrs. Ennis in the past, they probably taught you a famous phrase to help you with the inequality part. Go LA. How many of you remember that? Lovely. Now, if you don't, that's okay. I've got a little video here that should help us out. We're going to play that.
Determine if these absolute value inequalities represent and or compound inequalities. Well, to help us figure that out, we need to learn a rule. This rule states that if we have a less than symbol, then we'll have an and compound inequality. If we have a greater than symbol, we'll have an or compound inequality. Now let's use this rule to figure out the compound inequalities for each one of these absolute value inequalities. Let's take this first one. We have a less than symbol. That means we have an and compound inequality. Now all we need to do is get the inequalities on either side of the and. So, to get the first one, we rewrite our absolute value inequality without the absolute value. To get the second one, we flip the direction of our inequality symbol and then change the sign on the right. Now we have this set up as a compound inequality. Let's do the other one. We have a greater than symbol. That means we have an or compound inequality. Now to get the inequality. X minus 5 is greater than 3, or x minus 5 is less than negative 3. Now we've converted both of the absolute value inequalities to compound inequalities. But how do we know that this is correct? Well, to figure that out, let's graph our first compound inequality.
And we're actually going to pause it right there, because in that you were able to see the greater than symbol goes with or, and the less than symbol goes with and, right? And that's what that Go LA stands for. So if you've never heard of Go LA, you probably want to write that down. The greater than symbol, and the greater than symbol is this symbol right here, goes with which word? Or. And the less than symbol goes with and. Okay? So that's what that Go LA stands for. Now, if you noticed in hers, she sets up her and slightly different than I do. Okay? When we've talked about our and problems, we've always put our letters in the middle, right? So I'm going to show you how to set those up according to our standards, which are slightly different. So go ahead and copy down our first equation. The absolute value of x is less than or equal to 9. So this is an and problem. How do I know it's an and problem? The less than symbol, okay? So this symbol right here tells me it's an and problem. Now, if you notice, her first equation she set up was the exact problem, right? So I'm actually going to write that exact problem. But on the left side, I'm going to keep this exact same symbol, and I'm going to change this to a negative 9. So that is my and inequality. So all I've done was rewrite the exact same symbol and use a negative 9. Take a second and write down a little note so that you can remember this when you're doing tonight's essential work. Well, I kept the exact same symbol and changed this to a negative 9. Now, do I need to do anything to solve this? Or is it already solved? It's already solved. X is by itself, right? So if I was graphing this, what kind of a dot would I put at negative 9? Closed dot. And at 9, I would also put a closed dot. And I shade in the middle. Okay? Now, that one's there just so you can practice setting it up. But I'm going to have you practice setting number 4 up. So go ahead and write down number 4. And take a second to practice setting it up. Just exactly what we did here. So, Ty, tell me what you have. Let's see how you did. Wait, I don't need an answer. Can you just set up the problem for me? Okay, how would I set this up? Well, before I do that, how do I set up the problem? With the inequality signs and everything. Okay, so I have that beginning part, and then? Good. So when I'm talking about setting it up, that's all I'm looking for. So when I'm talking about setting it up, that's all I'm looking for, because the solving part is what you did last night, right? Now, if you didn't remember how to set that up, you need to write yourself a note right now. That future self needs a note. How did I just set that up so you can remember? And then take a minute, go ahead and solve that problem. So I'm going to go ahead and solve this, as you're still working on it, by adding 9 to all of my sides. Over here I get 30. 4x is in the middle. Right here, negative 21 plus 9 is negative 12. Then I'll divide everything by 4. So here I get negative 3 is less than or equal to x is less than or equal to 15 over 2 or 7.5. So Zach said, does it matter if I change it to a decimal? No. And I could do that one in my head easily, which is fine. Graph it now. Make yourself a number line. Now, notice my number line has every number from -10 to 10, but how many numbers do you need on your number line? That's all we need on there. -3 and the 7.5. That would also work. That would also work. So at -3, I've got a solid dot. And at 7.5, I've got a solid dot. And David, where do I shade? In the middle or on the outside? Not on the outside. Remember, if X is in the middle, we shade in the, there we go. And that's our little phrase to help us out with that. So you may want to write that phrase down to help you out. And those will be easy test questions then when we're working. So we've done the and problem. Now we need to do the or problem. So go ahead and copy down problem 5. How do I know it's an or problem? Somebody raise your hand. How do I know it's an or problem? Antonia. The greater than symbol. So this symbol here tells me it's going to be an or problem. Okay? Notice I wrote the word or. That's going to be necessary here. Now, see how this is just x is greater than or equal to 11? I write that on the right side. So I rewrite the problem on the right side without the absolute value sign. So I'll repeat that. I rewrote the problem on the right side without the absolute value sign. On the left side, I rewrite the problem without the absolute value sign, but then I switch this sign and I change this number. So I switch the sign and I change the number. Does everybody see how I got that? Okay. I like to think of or as opposite, so opposite sign, opposite number, if that also helps. Well, we set this one up. Take a minute. I want you just to set up that problem number 6. Just set it up. All right, Cody, tell me what you have. Okay. Cody, that's 100% correct. 100%. Go ahead and solve that equation and then graph it. So here we've already done the problem. We have the answers. Raise your hand if you have those 2 answers. Perfect. So far we're doing great. So I'm going to graph that. -16/3. I have a number line here, so I want to put it on correctly. What is that approximately? Good. I'm actually going to go a little bit below -5. Put an open dot, because it's actually -5 and 1/3. But that's perfect. 20/3. 6 2/3 is perfect. Okay. Notice I put open dot because there's no equal sign. And since it's or, I shade on the outside. Ah. Those lovely hints that I gave you. If X is in the middle, we shade in the middle. If it's or, it's outside. All right, any questions? Okay. So tonight, we do have some essential work. It is imperative to use your notes, so